In this video, I want to go over very briefly the difference between a vertical stretch and a vertical compression. And when you get into Algebra 2, you will learn more about this in greater detail. I just want you to walk into Algebra 2 having a general idea of what a vertical stretch and what a vertical compression is. So I started off here by graphing my parent function. Here are some of my x, y coordinate points for the parent function, and we call these anchor points. And again, when you get into Algebra 2, you will learn more about why we call these anchor points. But the x, y coordinate points for your parent function are called anchor points. So here is the graph for the parent function, and here are the anchor points. Now look at what I did. I took the parent function and I multiplied it by 2. I multiplied the entire function by 2. In other words, I gave it a vertical stretch by a factor of 2. So here are the xy coordinate points for this function. Now compare the xy coordinate points for this function with the xy coordinate points for the parent function. Notice what happens to the y values. What am I doing to the y values when I give the parent function a vertical stretch by a factor of 2? What I'm doing is multiplying the y values by 2. So now let's look at this anchor point here, 2, 4. Here is the anchor point for the parent function. And what happens when I give the parent function a vertical stretch by a factor of 2? Now the point is not at 2, 4. Now the point is at 2, 8. So what am I doing? When I give the function a vertical stretch by a factor of 2, what I'm doing is moving the graph further away from the x-axis. Again, your book says that the graph is getting more narrow, but what's really happening is the graph is moving further away from the x-axis. Now let's look at what happens when I give the parent function a vertical compression by a factor of 1/2. When I give the parent function a vertical compression by a factor of 1/2, look at what I'm doing. What I'm doing is dividing the y values by 2. So let's look at the same anchor point here of 2, 4. This is the xy coordinate point for your parent function. But then look what happens when I give the parent function a vertical compression by a factor of 1/2. Now my coordinate point is not at 2, 4. Now it's at 2, 2. So what am I doing? I'm bringing that graph closer to the x-axis. Your book says the graph is getting wider, but what's really happening is the graph is moving closer to the x-axis.